everyone, very good morning. I'm Monty and today I'll be presenting technical talk on fast forensics, automate triage data collection and analysis with Elastic. First thing first, I work at detection and response engineering team at CRED. We call it DARE team and we are the ones who protect CRED 24/7, 365 days in a year. And I was part of Awake team at Arista Networks. That's a US-based startup mostly focused on NDR before I was part of CRED. I do detection engineering, breach and attack simulation and incident response at CRED. We have multiple charters and we contribute to each of them. So these are some of the things I do there at CRED. I'm a BTech in computer science and engineering graduate from Indian Institute of Information Technology, and you can find me at the LinkedIn ID mentioned here. So what we are going to talk today, we'll look at why rapid forensic data collection is important, and in that we will also see what are the challenges with the current traditional approach to forensic data collection, and we will introduce the Velociraptor offline collector. That's again another open source project, and we'll leverage that and integrate it with AWS and then the Elastic to have a full analysis and triage and analysis framework. We'll look at the architecture diagram for forensic data collection, and then at last we will set this infrastructure up, see how do we configure the IAM policies, how do we set up the queues, and how do we set up the collector, everything. Importance of rapid forensic data collection. What are the challenges in the traditional forensic data collection methods? Most of you are already aware. So data volume is very high these days. For a personal computer, the disk size is in terabytes. So with traditional method, when you collect data, you basically acquire the complete disk. That take hours, and you need to have a storage. So for 1 TB disk size, you will have a 1 TB snapshot, and you just need to zip that and then take things out of it, artifacts out of it, and analyze it. So that will take hours and days, and it's very cumbersome and prone to errors also. And in that there will be variety of data types, right? Some of the artifacts, like registry artifacts, will be there, in case of Windows. EVTX will be there. So you will have CSV, JSON. So formats will be different. So each of these formats require a different pre-processing, right, before it can be ingested to Elastic for analysis. And that's one of the challenge. And of course manual extraction issues are always there. When you collect that image manually and you do a full disk image, and it's prone to error, it can fail, and you need to do it again and again. It can corrupt, so lot of issues. And of course there are always challenges with data integrity of that. Basically you need to take the hash of that complete thing and do it over and over again, and that's being. So do we actually need that complete disk image? Let's say you have an incident, right, and suppose one of your system is compromised, and you have been tasked to do the forensics of it. So do we actually need to collect that full disk image in order to answer forensic relevant questions? The answer is no. Only 1% of the data, the artifacts on that system, are the ones that actually provide value and can give you answers to the questions. So who, what, when, what happened, how happened, who did it, like all of this is in just 1% of the data. So why collect the full 1 TB disk image or 2 TB disk image and have pain of storing it? Let's just collect that 1%. And that's what we are going to do today, and we'll see how we'll do it today. So before jumping to how do we do it today, what are the benefit of automation in forensic data collection. So of course, speed and efficiency, process will be efficient, process will be faster. So basically collecting, instead of collecting the complete disk, you are just collecting the 1%. Of course, it will be fast and scalable and efficient. And since the process is automated, previously in the traditional approach, you had to manually collect the image and import it and do all sort of forensic stuff on top of it. Here, it's just an agent, you deploy and run it, and your task is done, your data is an elastic, and you just chill. So consistency is there because it's a standardized process, and you just have one agent run on 1,000 system, collect forensic data at scale without errors, as long as the agent functions. Accelerated forensic analysis, because one of the pain points in forensic analysis is machine acquisition and taking the snapshot of that infected machine and then do the analysis. So this first part takes a lot of time. Sometimes it takes even days to acquire that machine in case of physical server, or a lot of approvals and all. And if you just have as an agent, just push it through CrowdStrike, RTR, who knows, and just collect the data just in minutes. And of course, if this pain point is solved, you have the data, you can just identify the attack vector and do analysis, contain it, do the impact analysis, and you're done. Velociraptor offline collector. Open source project, we will use it has its own UI, but we will just use offline collector and integrate it with AWS and Elastic. So what exactly it does? It's a pre-configured binary. You can basically find that project on GitHub, and you can just run it locally on your system, or you can just run it in client server mode. We'll not go into how we do it because it's easy. GitHub instructions are there. We'll look at how do we leverage it for our use case. So since it's a pre-configured binary, you can bake in what you want to collect. So in this example, I am collecting forensic artifacts from an infected Windows system. So I have said, hey, in this binary, I want to collect the cave targets. Okay, that's a bunch of like registry stuff and EVTX and all the files. So it's a abstracted called cave targets. Now that binary knows, so whenever that is executed on any machine, that knows what it need to collect, right? It will collect the cave targets. Okay. But the question is what it will do with that. Where do it upload? What's the output? So Velociraptor offline collector comes with multiple integrations such as SFTP, S3 bucket. So for our use case, I'm using S3 integration because it has an easy out of the box integration with Elastic Cloud. We'll see again how we integrate the other end. So in here I have specified the target operating system as Windows, because this agent is in our scenario this will run on Windows, and collection type is AWS bucket. The bucket has to be created of course before running and configuring this collector. So please ensure that you have the bucket configured and the reason configured, and of course the credential key and secret. So these are long-term IAM credentials. I have already inactivated it, so it won't work. So if you are paranoid like me and do not want to bake in the long-term credentials into an infected machine, you can use STS token also. It also provide आपको that session token wala field. So that has a as per the best of my understanding, its expiration is from 15 minutes to 36 hours. So you can configure that also, but in that case you need to recreate this binary again and again, or you just have an automated process to do it. So okay, so once that is configured, you have the binary ready. You have baked into that the secrets. So now the binary knows that it has to collect the cave targets and upload it to S3 bucket in your designated region. So after some time, this collector you can download from here and just run it on the system. That's it. So it's just on one system, right? It's suppose it's an infected system and you have been tasked to collect forensic artifacts from the system to perform analysis and IR, all kind of stuff. So how you can scale it for Windows system via GPO? So you can just take this one agent and push it through GPO to thousands of your Windows systems, servers, anything in your environment. You can even configure it via scheduled task and say you just want to do a compromise assessment, okay, and you just want that you want to do collect all these artifacts every day, like, or once a week, and do all sort of correlation analysis on it, how you do on logs, right? You can do continuous monitoring or compromise assessment on top of forensic artifacts also. So it's more of fast forensics, say continuous forensics. So you can also do that. In case of Mac systems, you can use something like MDM and push it, configure cron job and collect it every day, or just do it once when you have been notified by the SOC team that there is an incident and it need a forensic analysis. Just run it, push it and run it. So architecture diagram. So up to now what we have done, so we have the Velociraptor client and we executed it and the data was uploaded to S3 bucket. So up to here it's fine, right? So now how this data goes to the Elastic to be consumed by analysts. So S3 bucket has an feature, out of the box feature for SNS and SQS. So for data, so whenever new data is uploaded, it triggers a SNS notification, which in turn triggers a SQS message. And you can ask why directly SQS and why SNS. So if you have SNS, you can have multiple consumers, and so matlab, you can just feed the data to more than one destinations. And so every time new data is uploaded, in our case it will be forensic artifacts, you get notified and the message in the queue. So in here I have an Elastic agent running on EC2 instance. You can also run it on ECS, but for the sake of simplicity and because the forensic artifact that you collect are not that large, we have already reduced the size to 1%, and then we have specified that we just want to collect cape targets. So the size is very low, so I have used EC2 instance, and on top of it I have installed the Elastic agent. Now from the Elastic Cloud, you can configure Elastic policy on top of it. So it just defines how that agent behaves, what exactly the agent will do. So in our case, we applied the custom AWS log integration policy on the instance installed here. And what basically it does, it helps, any data in the bucket, this Elastic agent can pull it from the bucket and push it to Elastic stack because of the custom AWS log integration policy configured on top of it. So we will also see it's an out of the box policy, no need to do anything, it's just fill it and you're done. So let's see how do we set up each of these components of that architecture, of this architecture diagram. We have already seen how the Raptor client works, and S3 bucket is fairly simple. So let's just see the other components of it. Setting up infrastructure. Create an IAM role. This is the most important thing. So Elastic agents that we saw previously that is running on EC2 instance, right? So that need an IAM policy attached to it so that it can pull the logs from your S3 bucket, and also it needs SQS access so that it can read the message from it and basically change the visibility and delete the message. So if you see this IAM role, will basically be applied to the EC2 instance on which the Elastic agent is running. There are two parts to it. One is the SQS access, where I have created a SQS queue, right? And on top of this resource, I have allowed delete message, receive message, all sort of stuff, so that Elastic agent will be able to see any new message coming to it. And then Elastic agent should also be able to get object from the forensic artifact bucket which you have specified. Hence this policy. So agent will be able to pull the logs from the S3 bucket and push it to Elastic stack. So this is the minimum required permission, right? You can I think this is the most granular thing you can do. You can give overly permission, just do star and star, but I just like to have more granular policy than having a blind or wildcard policy. So SNS out of the box, go to S3 S3 configuration, and I have created a new event notification, pardon the name. So whenever new object is uploaded, it triggers an SNS topic, and this in turn goes to this test123. That's the destination, and then you have an SQS queue, right? So from SNS it goes to SQS queue, and notice the URL, this URL which we will be using in the Elastica configuration. And in here the test123 which we saw in the previous, though it's like SNS to SQS. Uh, Coming to the, so in our architecture, I am using Elastic Cloud because it's simple. You need not to do any platform management, just sign up and do the configuration and do security. So if you go to the integration, there are custom AWS log integration. So I am using this one to pull the log from my S3 bucket, and the queue URL which you configured in 2 slides back, you just put it over here and you specify the data set name. That's basically an index where you want to keep the data. Give it any fancy name you want. And next thing is that Elastic agent we saw. That Elastic agent was running on the EC2 instance. So how exactly you deploy that? So I'm using the Linux wala EC2 instance, hence I get out of the box command. I just need to copy it and run, and that's it. Agent will be enrolled. So agent is there running, and the policy is also attached to it, right? At this point, whenever new artifacts are uploaded to the S3 bucket, triggers an SNS to SQS, and then Elastic agent works, get the logs and feed it to Elasticstack. What's next? How do you analyze this data? So do a simple search, write boarding, or just integrate Sigma with it. So Sigma is another open source repository of tools, open source repository of rules. And you have many hunting rules on it. In fact, at CRED, we have deployed a lot of hunting rules for Mac OS, some 50-55, directly sourced from Sigma and converted into Elastic. So this Sigma has a converter called Sigma C, and you can basically convert it into languages such as Lucini or other language and just import it to Elastic. You can do all sort of programmatic stuff here to use Elastic API directly, and instead of manually importing the rules, creating the rules, just create a detection pipeline and just do it via API. So what we have understood now is that the forensic artifacts, we have converted it into logs, consumed it as logs and analyzed it as logs, and we can do it continuously, right? So now we have more visibility, right? And yeah, that's it. Any questions? On time?
You completed before time, so we got a good time for a Q&A. Now I'm welcoming all the questions. Start bombarding to the Monty. Yeah. Any questions, folks? Yeah.
So with the current EDR solutions integrated with OS query, that is also a well-maintained open source project. So Velociraptor can be eliminated, right?
It can be, but it's about the stability, right? Yeah, but it's just a matter of preference what you want to use.
Hi.
Hi.
Just curiosity to know, like you are using an Elastic agent to store the logs of forensic. How you are taking care of that EC2 instance logs or alerts of that if agent goes down, or else any interruption happened to the agents? How you are taking care of that?
Health check is there, so in Elastic Cloud you get option for health check. Otherwise you can just, as I mentioned also in the architecture diagram, my volume was low, so I was using EC2 instance pay Elastic agent. For scalability you can use ECS.
Okay, thank you.
So just to clarify, you already have some kind of an EDR system running. You're in addition installing the Velociraptor.
On demand.
But have you considered installing the Elastic Agent on the source itself, right? And you could do the same thing. You don't need the Velociraptor step in the first place.
I fear I will be able to abstract the artifact. So I need to manually go and configure everything I want. With Velociraptor, the upside and the USP is that you can just click through it and get the artifacts you want. So for forensic cases, you need different artifacts, right? In this case, I needed cape targets.
But
So
then to execute the Velociraptor binary, you're going to use some other
GPU.
Yeah, you're going to use RTR, like you mentioned, CrowdStrike or something. Okay.
Or you can just do it via GPU. Or you can configure scheduled task also, as I mentioned.
Yep.
Anyone? Yeah, go ahead.
So once you collect the artifacts and it is in the EC2 instance, so how do you parse it? Like, for example, you collect MFT file, I want to parse it. You install additional modules, or
any output of the Velociraptor will be in JSON format. You need to use the custom pre-processing to get the data in.
okay, so no, for example, you do targeted cape collection, right? So it collects the artifact itself, $MF, for example, $MFT file. Where does it get parsed as an output?
On the source itself.
On the source itself.
And then it gets uploaded to S3 as JSON.
As JSON. So the timing for collection, have you identified any kind of time it takes? How long does it? Because it has to collect and parse.
So I was running it on my system and it just took within 25-30 seconds. But again, it will depend on the size of the system also and how old the system is. The older the system is, the MFT size and registry size, everything will be high. So more time it will take to parse it.
So how do you monitor, how do you monitor if it runs successfully?
We'll take it offline.
There's a gentleman. One last question. I would request just to keep short. I think you can just, yeah, you can shout out. Okay, it's okay. Community track. Yeah.
It's already in. You told it's in JSON format. I did not find the reason why you pushed it into EC2 and then you pulled it from Elastic. You could have directly given that to Elasticsearch, right? There is. It's a better option, is what I feel.
Yeah, I prefer using Elastic Agent to provide scalability, as I told that you can, instead of EC2 you have ECS, right? So for Velociraptor data, if you are collecting at scale on 1,000 systems sometimes, so you need to scale that up, right? So for that matter, I'm using Elastic Agent.
Elastic auto scaling would work there. Elasticsearch cloud auto scaling.
I'll look into it.